factors and multiples. Mrs. Navarro is arranging desks in her classroom. There are 24 desks. How many ways can she arrange the desks so that the number of desks in each row is the same? Two or more numbers that are multiplied together to form a product are called factors. To find the different arrangement of desks, break down or decompose 24 into its factors. Think of number pairs that result in a product of 24. 1 times 24 equals 24. 2 times 12 equals 24. You can multiply 3 times 8 to get 24. Multiply 4 times 6. The result is 24. There are 4 more arrays. 24 times 1, 12 times 2, 8 times 3, and 6 times 4. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. There are 8 factors, so the desks can be arranged in 8 ways.
Now we are going to start working on pages 485 and 486 of your math packet. It looks exactly like what we would do in class, so I want you to make sure you have it in front of you and you're working on it with me. Okay, if you look up over here in the corner, let me turn my pen on so you can see it. This is our standard for today, 4.08.4, which says find all factor pairs for a whole number in the range 1 through 100. So our I can statement, or what you are going to be able to do by the end of this chapter, is find all the factor pairs for a whole number in the range from 1 to 100. Repeat after me. I can find all factor pairs for a whole number in the range 1 through 100. You can do it. Let's get started. Okay, let's look at right here. Let's read this together. Factors are numbers that are multiplied together to form a product. The two factors that are multiplied together are the factor pairs of a product. Couple things that we need to remember. A product. What is a product? Think to yourself about what a product is. A product is the answer to multiplication. So 1 times 2, the product is 2. 3 times 3, the product is 9. So what we are going to be doing is figuring out what two numbers work together to make a product. Okay, we're going to be given the product and we're going to have to work backwards and figure out what two numbers make that product. Example 1. A chef is arranging 48 strawberries in an array on a tray. Find all the factor pairs of 48 to see what kinds of arrays can be made. Draw and label one of the arrays. So there's a lot we need to do. Okay? First it says think of multiplication equations that result in a product of 48. So like I said, it gave us our product. It gave us the answer, which is 48. Sorry, my pen's a little thick. Let me see if I can make it smaller so that doesn't happen. Nope, now it's not going to let me draw at all. Remember, guys, I'm new to this, so you got to be patient with me. Hello, pen. Let me see if I have to change it like this. There we go. Perfect. Think of a multiplication equation that results in a product of 48. So what numbers are going to work together when multiplied to get 48? It gave us 1. 1 times 48 equals 48. Think about what property tells us any number times 1 is that same number. Did you think identity property of multiplication? Because that's what it is. So anytime we are talking about factors, we always know that 1 times whatever product we are given is going to be a factor, because 1 times any number is that same number. Then it gave us 2 times 24 equals 48. 2 and 24 are a factor pair of 48. When you multiply 2 times 24, you get 48. Now it gave us 3 times a blank equals 48. So we need to figure out what number can you multiply by 3 to get 48. So there are a couple ways you can do this. If you have your multiplication chart, you can look at that. You can skip count, okay? But you need to figure out 3 times what number equals 48. Or you could work backwards and divide 48 by 3. Let's do that off to the side. Oh, it's not going to let me write again. There we go. 48 divided by 3. The first thing we need to do is at the top write our steps to division. DMSB, divide, multiply, subtract, bring down. Okay, we know how to do this. This is just a quick review. How many times can 3 go into 4? 1 time. 1 times 3 is 3. S stands for subtract. 4 minus 3 is 1. Bring down my 8. 3 goes into 18 how many times? 6. Write it at the top. 6 times 3 is 18. Subtract 0. We got a 0 at the bottom. We have all of our quotient filled. We are good to go. So 3 times 16, it's a really bad 6, equals 48. So 3 and 16 are a factor pair of 48. 4 times what number equals 48? 4 and divide, skip count, or check out your multiplication chart and see what you get. I'm going to try and erase this division problem. Oh, it's not going to let me erase it. Guys, I feel like I'm using the smartboard here. Okay? We'll just go back to our pen. It's okay. Okay, did you think about it? 4 times what number equals 48? 12. Oh, I like that pen better. That shows up better. Okay? So 4 and 12 are a factor pair of 48. Last one, 6 times what number equals 48? You could divide 48 by 6. You could skip count by 6 until you get to 48. Or you could look at a multiplication chart. Okay, I would use my multiplication chart as my last resort because we won't always have that. But we can always divide and we can always skip count. So try and figure out what 6 times what number equals 48. Did you come up with anything? 8. 6 times 8 equals 48. So 6 and 8 are a factor pair of 48. 48 is a multiple of each of the factors above. That means if I count by 1, 2, 3, 4, 6, 48, 24, 16, 12, or 8, if I skip count by those numbers, at some point I will say 48. 2, 4, 6, 8, 10, 12. If I keep going, I will say 48. 4, 8, 12, 16. If I keep going, at some point I will say 48. 48 is divisible by all of these numbers, so it is a multiple. Okay, so the following arrays can be made. 1 times 48, 2 times 24. I'm going to overlap into my division a little bit. 3 times 16, 4 times 12, and 6 times 8. So we just needed to think about all the different all the different multiplication equations we could get to get the product of 48. Now we need to create an array. It says draw and label one of the arrays. So we don't have to draw an array for all of these. We just need to pick one. I'm going to pick 6 times 8. Okay? So I'm going to put 6 across and 8 down. Remember, this top dot counts for both, okay? This top dot counts for my 6 and my 8. And then I'm just going to fill in the rest. It's not the neatest array. I bet yours looks a lot better than mine. And I'm going to do this, and when I count it all up, I should have 48 dots. Are you still doing it with me? Keep going. Okay, good job. We're going to move on to the next page. I'm going to clear this whole page off, and we're going to move to the next page. Okay, if you still need to look at that page, just pause the video really quick, finish that page, and then press play and continue with us, okay? Example 2, determine whether 68 is a multiple of 4. So I need to think about what that's asking me to do. I'm not thinking about factoring anymore, so I'm not going to try and figure out all the factors of 64. But I need to figure out if I skip count by 4, will I ever say 64? Okay? So there are 2 ways that we can do this. The first way is we can divide. So let's work on that one first, okay? Let's do one at a time. I'm going to turn my pen back on. Okay, so one way is to divide. Long division. I know it's still kind of tricky for some of us, so I'm really glad that we're doing this and keep practicing it. Okay, think about what we write at the top of our paper for long division. Write it at the top. D, M, S, B, S. Oh, I don't know why that's not writing. There we go. Divide, multiply, subtract, bring down, start over. It gave us our problem, 64 divided by 4. So let's solve it. The first thing I need to do is divide. Okay, so I'm going to cover up my 4, and I'm going to look at 6 divided by 4. What number times 4 gets me close to 6, or how many groups of 4 can I put into 6? Do you know the answer? 1. Now I need to multiply 1 times 4. Any number times 1 is that same number. That's our identity property of multiplication. So 1 times 4 is 4. Now I need to subtract. 6 minus 4 is 2. And I bring down 4. And I start over. Okay, sorry if you can hear trucks outside my house. They're taking out all the recycling. Okay, so now I need to start over. Now I have 24 divided by 4. What number times 4 gets me to 24, or how many groups of 4 can I put into 24? Or 24 divided by 6 if you just know that fact off the top of your head. 6. Now multiply. 6 times 4 is 24. And subtract. 24 minus 4 is 0. Got a 0. My quotient is full. So 64 divided by 4 is 16. There's no remainder, so 4 divides 64 evenly. So 64 is a multiple of 4. If there was a remainder, if it said 16 remainder 2, then it would not be a multiple because it doesn't count evenly into 64. Okay? If I was skip counting by 4, I wouldn't say 64 if there was a remainder. But since there's no remainder and it's just a whole number, then it is a multiple. So 64 is a multiple of 4. Good. Now, look at the one where it says another way. List multiples of 4. Remember, when we were finding multiples, we were just skip counting. So what you need to do is just skip count and fill in all those lines. So 4, 8, 12, 16, 20, 24, 28, 32, 36, oh, it's not writing, 36, 40, 44, 40, that's supposed to be 48, 52, 56, 60, 64, etc. Etc. just means we're going to keep counting. Okay? Did we ever say 64 when we counted by fours? Absolutely, right here. This is 64. So you can count by 4 to get 64. So 64 is a multiple of 4. So we've just talked about how to factor and how to find multiples. Now we're going to move on down here to our guided practice. This is where we're doing it together. Normally in class I would ask questions and we would talk about it, but we can't really do that since I'm by myself and you're just watching my videos. I wish we were together, but since we can't, I'm just going to think aloud and model how to solve these. And then you're going to do the independent practice by yourself. And then I'll post the answers for that and go over it with you. And then you're completely on your own for the homework, just like we would at school. I'm trying to make this as close to how we would do math at school, okay? I will post the answers for the homework later, so if mom, dad, grandma, grandpa, aunt, uncle, brother, sister, whoever wants to help you and go over those, they can. And if they have questions, they can contact me. All right, so let's jump down to guided practice and we'll keep going through some math. First, we need to find the factor pairs of each number. So we need to figure out what numbers multiplied together will get 46 and 76. So let's start with 46 first, since that's number 1. Think back to a couple minutes ago, I said anytime you are doing factors, there's one factor pair that you will always have. Do you remember what it is? That identity property of multiplication? 1 and whatever number you are working with. So in this case, it's 46. Okay? 1 and 46. If it was 27, it would be 1 and 27. If it was 2, it would be 1 and 2. Identity property of multiplication, okay? Now, what other factor pair is there for 46? We need to think about what other numbers we could multiply together to get 46. Well, I see that this number ends in a 6, which means it's an even number, which means it can be divided by 2. So I can put 2, and now I need to think about what number multiplies by 2 to get 46, and it's 23. Those are my factor pairs of each number. I can't divide it by 3 or 4 or 5. It's 1 and 46 and 2 and 23. Gotta take a sip of my coffee. All right, moving on to number 2. 76. Well, we already know 1 is going to be a factor, and the number we are working with, which is 76. Now we need to think about another one. The number ends in an even number, so it's divisible by 2. So 2 and what number equals 76? Let's do some division. Okay, if we don't know, we can always divide. Right at the top, D, M, S, B, S. We always write that with our long division, which helps us divide, multiply, subtract, bring down, start over. Those are our 5 steps to long division. If we write those steps out at the top and we remember them, we are able to solve any long division problem. Okay, so let's divide first. 7 divided by 2. How many groups of 2 can I put into 7? Or 2 times what number gives me 7 or gets me as close to 7 as I can be? Anything? 3? Good job. If you said 3, you're on the right track. So now we need to multiply. 3 times 2. Subtract. 7 minus 6 is 1. B stands for bring down. 16 divided by 2. 8. 8 times 2. 16. S. Subtract 0. We got a 0 and our quotient is full. So 2 times 38 is 76. Let's see if I can use this eraser. It does not like me when I try to erase. Oh no! It does not like it when I try to erase, friends. That's okay. We'll just go back to our pen. We'll just have to squish it all in together. All right, now we have one more factor pair that we need. So we could count by threes, because that would be our next number, 1, 2, 3. To see if we get 76, we could skip count by 4, 5, 6, 7, 8, 9, 10, or you could look at your multiplication chart, okay? If you look at your multiplication chart, you would see that 4 goes into 76, okay? So 3 doesn't, but 4 does. Of course, now my pen's not going to work. Let's see if I can turn my pen back on. Ah, there we go. 4. Now let's go up here. I'm going to do some more long division up here. 76 divided by 4. 7 divided by 4, or how many groups of 4 can I put into 7? Or 4 times what number gets me close to 7? 4 times 1 is 4. 4 times 2 is 8. Well, 8's bigger than 7, so I can't go all the way up to 2, so I have to go with 1. Now, looking at my steps, multiply. 1 times 4 is 4. Subtract. 7 minus 4 is 3. Bring down 6. 36 divided by 4. Well, I know my 9's rule. And 36 divided by 4 is 9. Multiply 9 times 4 and you get 36. Subtract, you get 0. I have a 0 at the bottom. My quotient is full. So 4 and 19. A lot of factoring is trial and error, guys, which means you are going to just have to keep trying math problems to figure out what factor pairs you can make. Sometimes you'll divide and it won't work out, and that's okay. That just means it's not a factor pair. Sometimes you'll skip count and won't say that number. That's okay. That means it's not a factor pair. Okay, more times than not, you're going to try numbers that will not work, but you have to be persistent, which means you have to keep trying and not give up. All right, jump down to number 3. Is 66 a multiple of 6? If I divide 66 by 6, will I get a whole number with no remainders? Or if I skip count by 6, will I ever say 66? What do you think? Think about it. Let's divide. 6 divided by 6, 1. 1 times 6 is 6. Subtract 0, bring down a 6. 6 divided by 6 is 1. Multiply 1 times 6, 6. Get a 0, and my quotient is full. So can I divide 66 by 6 and not get any remainders? Absolutely. So it is a multiple. Or I could have skip counted by 6, 6, 12, 18, and I would have said 66 eventually. Is 86 a multiple of 4? If I skip count by 4, will I ever say 86? 4, 8, 12, keep going. Giving you a minute to skip count. Did you say 86? Okay, now take a minute and try and divide 86 by 4. Oh, it won't let me get that far off the page. Hold on. I tried to divide it for you. 86 divided by 4. No, it does not work, so it is not a multiple. Is 78 a multiple of 3? If I skip count by 3, will I say 78? Or if I divide 78 by 3, will I get a whole number with no remainders? How many groups of 3 can go into 7? 2 times 3 is 6. 7 times 1 is 1. Bring down my 8. 18 divided by 3 is... Anyone? 18 divided by 3? Think about it. If you said 6, good job. 6 times 3. Did I get a whole number with no remainders? I sure did. So 26 is the answer to 48 divided by 3, or our quotient. So 78 is a multiple of 3. I know I have a lot going on this page. There's a lot of writing. I'm going to work later today on figuring out how I can erase this better so it's not as confusing when you look at it. All right, we are going over the independent practice, pages 478 of your math packet. You should have already done this page by yourself. I'm just quickly going to go through and review the answers. If you don't get them all right, that's all right. Go back and watch the lesson video. I'll post a couple other videos that have to do with factors and multiples to help you from YouTube. But this is just to go over what you've done by yourself and make sure that we really understand factors and multiples before we move on to our next lesson tomorrow. Okay, so we're going to go through this rather quick, so try and keep up with me. And if you need help, reach out to me and I can give you some extra work and resources and chat with you about how to work on factors and multiples, all right? So number 6, find the factor pairs of each number. 66. Well, I know that anytime I'm trying to find factor pairs, I'm always going to have 1 in whatever number we are working with, which is 66. Identity property of multiplication. 66 is an even number, so it's always going to be divisible by 2. And if I skip count by 2s, I have to skip count 33 times to get 66. 6 is divisible by 3, so I'm going to see if I skip count by 3s if I will ever say 66. So I'm going to go to my multiplication chart and look at 3. 3, 6, 9, 12, go all the way up. I get to 60 on my multiplication chart, so I could just keep going. 60, 63, 66. I do say it, so it's 3 and 22. And since it's 6, 6, which are two numbers of the same right next to each other, I know that it's divisible by 11. Anytime that you have a number that's the same number, like 44 or 55, 66, 77, those numbers are all divisible by 11. And it's 11 times whatever number is made up in the number, so 6. If it was 77, it would be 11 and 7. If it was 22, it would be 11 and 2. Okay, so those are my factor pairs for 66. Number 7, 54. Well, 1 and 54, we know that one. It's an even number, so 2 and 27. What else? 54 divided by, let's go to our multiplication chart. If I count by 3s, will I ever get to 54? Sure will. So 3 and 18, multiplication chart. Let's look at 4. I get to 52 and I go straight to 56, so that's not 1. 5. Well, if it's going to be a multiple, or if 5 is going to be in a factor pair, it's going to end in a 5 or a 0, and 54 doesn't do that, so it can't be 5. 6. Well, I already know 6. I know that 6 times 9 is 54. So 6 and 9. Okay, number 8. 8's super easy. There's only one that you need to find, and it's 1 and 59, because we know that 1 times that number is always a factor pair. I want to talk about something really quick since we are on this one. There's only one factor pair. That is because 59 is a prime number. You cannot multiply any other numbers together besides 1 and 59 to get 59. It's never going to happen. Okay, it's a prime number. It can only be divisible by itself or by 1. Okay, we're going to talk about more about prime numbers and composite numbers in the next chapter, but I just want to give you a quick preview. Number 9, 1 and 58, obviously, and it's an even number, so 2 and 29. Number 10, 70, 1 and 70. It's an even number, so 2 and 35. It ends in a 0, so I'm going to bet if I skip count by 5s, I'm going to say 70. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Sure thing. So 5, and I had to skip count 14 times. And since it ends in a 0, I bet if I count by 10s, I'm going to get to 70. 10, 20, 30, 40, 50, 60, 70. Yep. So 7 and 10. Sometimes you can just look at a number and you know fact pairs that always go into that number. Like 7 and 10 is 70. That's a quick fact pair that we know. 11, 93. Well, 1 and 93. I don't know any other numbers that go into 93, so I'm going to just start skip counting and see what I get. If I skip count by 2s, will I ever say 93? Well, 3 is an odd number, so no, I can't skip count by 2s. But it ends in 3, so maybe if I do 3. Maybe if I divide 93 by 3. Okay, when we divide DMSBS, writing that at the top of my paper so I remember my steps to division. 9 divided by 3 is 3. 3 times 3 is 9. Get 0, bring down by 3. 3 divided by 3 is 1. 1 times 3 is 3, and get 0. I have a 0 at the bottom, and I have a quotient without a remainder, so 93 is divisible by 3. So my factor pair is 3 in whatever my quotient was, which is 31. Number 12. 12, 13, and 14 get a little tricky because it doesn't tell us how many factor pairs there are. We just have to try. Okay, I'm going to clear this page so all my work didn't run in together, okay? So for number 12, we need to just start figuring out what our factor pairs are. We can skip count, we can use a multiplication chart, or we can divide. Okay, so when I did this problem, I got 1 times 60. That's my comma. I got 2 and 30. I tried 2 because I see that it's an even number. It ends in a 0, so I tried 5 and got 12. Since it ends in a 0, I also did skip counting. So I did skip counting by 10, so I got 6 and 10. And then there were a couple other ones that worked too. 3 and 20 and 4 and 15. Those ones I just had to divide and see what other numbers I could work that would go into 60. Okay, for 65, I got obviously 1 and 65. And then since it ended in a 5, I tried skip counting by 5s, and I got 5 and 13. And those are the only ones that worked for 65. And then 37, I know that 7's a prime number. Like I said, we're going to talk more about that. And so I knew that there was only one factor pair that could go into 37. 1 and 37. Okay, number 15. For exercises 15 through 18, write yes or no. Is 67 a multiple of 5? So if I skip count by 5s, will I ever say 67? No. Is 75 a multiple of 3? If I skip count by 3s, will I say 75? Look at your multiplication chart. I get to 60, keep going from there. 60, 63, 66. Trying to give you some time so you can skip count. Yes, you will. Is 72 a multiple of 4? If I skip count by 4s, will I get to 72? Let's look at our 4 line. It does get to 72, so yes. And if I skip count by 6, will I get to 69 for 18? No. Next one, 19, 20, 21. Circle the numbers that are multiples of each given number. So it gives you a 3, and you need to circle all the numbers that are multiples of 3. So if I skip count by 3, will I ever say 14? No. Will I say 18? Yes. Will I say 27? Yes. Will I say 70, or will I say 32? No. Will I say 45? Yes. And will I say 60? Yes. Number 20, 7. If I count by sevens, will I say 24? No. Will I say 38? No. Will I say 42? Yes. Will I say 63? Yes. Will I say 71? No. Will I say 84? Yes. Number 21, number 9. If I skip count by nines, will I say 30? No. 35? No. 54? Yes. 82? No. 90? Yes. All right, so that is our independent practice for lesson 1. What you need to do next is do the homework for lesson 1. And I'm not going to post a video for that. I'm just going to post the answers to go over it. And you can go over that with mom, dad, grandma, grandpa, aunt, uncle, brother, sister, whoever you want. And if you need help or have questions, have them message me on Dojo or call me on my Google Voice number or email me, and I'll reach out to you guys and make sure that you get your help on your homework. All right? Tomorrow when we start lesson 2, we'll do a quick review of factors and multiplying. All right, I'll see you guys tomorrow for lesson